particle falls from rest from a point P. When it has fallen a distance 19.6 meters, a second particle is projected vertically downwards from P with initial velocity 39.2 meters per second. The first particle, which I'm calling particle 1, has fallen a distance of 19.6 meters from this position here called P. At the instant particle 1 is 19.6 meters below P, a second particle, particle 2, is projected vertically downwards from position P with initial velocity 39.2 meters per second. Both particles have the same acceleration. So the acceleration vectors are shown in blue. Before we go any further, I will get the velocity of particle 1 when it is 19.6 meters from the position that it was dropped from. Now I'm taking the downwards direction as positive here. Particle 1 was dropped from rest, dropped from this position here. So its initial speed is 0. Its acceleration is plus 9.81 because downwards is positive. The distance it has fallen is 19.6 meters. S is also positive. Interestingly, when we calculate v, we get 19.6 meters per second, the same as the distance of particle 1 from the position that it was dropped from. The particles collide at a distance d from P. Find the value of d. So here's a picture of the situation when the two particles collide. The two of them are at a distance d from point P. So you can imagine starting the timer when we have this situation. So this situation occurs at t equals 0. Let's look at the distance s1 of particle 1 from its initial position P at any time t later. Of course, we'll be interested in the time when particle 1 collides with particle 2, but this t stands for any time. Now this formula is s equals ut plus a half at squared applied to particle 1. The only difference is we have to add on 19.6 because at t equals 0, which is this situation here, we have that s1, the position of particle 1 is 19.6. So at t equals 0, particle 1 is not starting at the origin. The origin is this point here, s equals 0. So we just have to add on this extra term to ensure that S1 is 19.6 when t is 0. So what is the velocity u1 of particle 1 when t is 0? Well, it's this value here, 19.6. The acceleration of particle 1 is the acceleration due to gravity. It's 9.81. So we've half of 9.81, which is 4.9. Now let's look at the second particle, particle 2. At t equals 0, s equals 0 for particle 2. So here's our familiar formula applied to particle 2. If you put 0 in for t, you get 0 for s. So we don't have to add anything on here because it's starting at the origin. Its initial speed is 39.2 because it's launched. It doesn't drop from rest. So S2 is 39.2 times t. The acceleration of it is 9.81, the same for the acceleration of any object near the Earth's surface. Half of 9.81 is 4.9. Now when the objects collide, the distances of both objects from point P is the same. So S1 equals S2. So basically we just have to equate these two. And we solve for the time. And that will give us the time taken for both particles to be equidistant from point P. That means the time taken for both particles to collide. So when we solve this equation, we won't end up with a quadratic. we get just one solution. We get t equals 1. So it takes 1 second for the particles to collide. So now it's just a matter of finding the value of d. D is just S1 or S2. So we just plug this value of 1 back into either of these. Doesn't matter, we'll get the same answer. I've plugged 1 into S2 and I get an answer 44.1 meters. Another method for doing this question would be to set the timer to t equals 0 at the instant that particle 1 falls from rest. So particle 2 hasn't come into the problem yet. Particle 2 will be launched vertically downwards when particle 1 has reached a distance of 19.6 meters. So the first thing I will do is get the time taken for particle 1 to travel a distance of 19.6 meters. So again, I take the downwards direction as positive. The distance s is going to be plus 19.6. The acceleration is going to be positive. The initial velocity of the particle is 0 since it falls from rest. So we plug everything into this and solve for t. We get t equals 2 seconds. At the instant that particle 1 is here, that is at t equals 2, particle 2 is launched vertically down with initial speed 39.2. Now let's suppose that t seconds after particle 2 is launched, the two particles collide at a distance d from their original positions. So this means that particle 2 will have been travelling for t seconds when it collides with particle 1. However, particle 1 will have been travelling for t plus 2 seconds when it collides, because particle 1 was travelling for 2 seconds before particle 2 was launched. So these are the travel times for the particles up till they collide. S1 is the distance travelled by particle 1 when it collides. That's equal to its initial velocity, which is 0 because it was dropped from rest, times the time taken for it to collide, which is t plus 2, where t is the time taken for particle 2 to collide. So the collision happens t seconds after 2 seconds have already elapsed. So the gap between the times for these two situations is t seconds. So this is just 4.9 times t plus 2 squared, and that's equal to d. Here's the formula for the distance travelled by particle 2. The initial speed or velocity is 39.2. T seconds elapse until it collides with particle 1. So we just have t here. The acceleration is 9.81 in the downwards positive direction, so half of that is 4.9. So this is also equal to d. So we just equate these two expressions and solve for the time. Solving this, we see that the quadratic terms disappear, so we're only going to get one solution, which actually makes sense because the particles only collide at one particular time. As before, we get t equals 1, and we plug that value of t into either of these, I plugged it into this expression here. So as before, we get 44.1 meters.